Welcome to our online lessons and welcome to Robertson View Academy. So we offer tuitions online for Form 1, Form 2 up to Form 5. We also do pure mathematics, pure science at university level or college level. So now, if at all you are interested in tuitions and also for the GCEs, if you are interested for tuitions, we have online classes and also physical classes for those who are near Choston, Kamanga, Overspill, and so forth. So we are located in Choston. Now, today we are looking at the other part of calculus, the other unit, and in this case, the subtopic that we are looking at specifically, it is called the equation of the tangent and that of the normal. Okay, so we are looking at the equation of a tangent and that of the normal. Okay, equation of the tangent and that of the normal. Now, when looking at the equation of the tangent and that of the normal, there are a few things that you need to understand and to take into consideration every time as you are doing this mathematics. So this is the subtopic of calculus. Okay. Now, let's say we have a Cartesian plane. Okay, this is the Cartesian plane, and we have the y-axis, and we have our x-axis. So the equation of the tangent and the normal, let's say to the k. Okay, to the k. Equation of the tangent and the normal to the k. Now, when looking at the equation of the tangent and that of the normal to the k, we have the Cartesian plane here. Okay. Now, under this one, we have a k. This k represents an equation. It can be y is equivalent to x. Now, I'm just representing this as an equation of this k. Okay. Now, you have to know how you can. You need to know what a tangent is, and you need to know what the normal is. A tangent is a line that touches the circle at only one point. So if I have a circle here, and there is a line that touches this circle only at this point, hence this is called a what? A tangent. Okay, so we have a tangent. Look at this. We have a tangent which is touching the circle only at this point. We are saying this line is what? A tangent. Tangent. Okay, this tangent is going to be represented. Its gradient will be called M1. The gradient of the tangent is called M1. Then, since this is the tangent, then a line that is perpendicular to the tangent, hence it is called the normal. So when we say perpendicular, meaning at the point of contact here, it makes an angle of 90 degrees. So this line here, which is perpendicular to the tangent, it is called the normal. And the gradient of the normal, it is called M2. That's what we're going to be representing it, how we're going to be representing it. Now, the thing that you have to understand here is that when you multiply the gradient of the tangent with that of the normal being M2, your answer must be a negative 1. Okay? The gradient of the normal and that of the tangent to the curve, our answer must be a negative 1 when we multiply them. Now, assuming to say you find your gradient of the normal to be 2. Okay, this is your gradient of the what? Of the normal as your M1. Now, how do you determine the gradient of the tangent? So to determine the gradient of the tangent, you've seen that what is our M1? Our M1 we said it is 2. When we multiply this M1 by M2 being that of the tangent, being that of the normal, so gradient of the tangent is 2 for M1. Then when we multiply the gradient of the tangent by that of the normal, our answer must be a negative 1. So since we are looking for now that one of M2 being the normal, we divide both sides by 2 and here by 2. So this one, then M2 is equivalent to this one, negative 1 over 2. So now if our negative 1 over 2 is the gradient of the normal, then we need to understand that what was that one of the tangent? It was 2. By the normal is negative 1 over 2. We can add the 1 here to balance out. This multiplied by this will give us negative 2. This multiplied by this will give us 2. When we divide this into this one, it will give us a negative 1. So that is why we are saying that when we multiply the gradient of the tangent and that of the normal, the answer must be negative 1. Similarly, when we have, let's assume to say our m1 is what? Is 5. How do we determine m2? We just reciprocate. Okay? If how do we find m2? So we can say, okay, m1 by m2, okay, is equivalent to what? To the 1. What's our m1? It is 5 by what? By m2 is a 1. We'll say over 5 and over 5. Okay, so m2, you see this into this one, a 1. And m2 is equivalent to what? To negative 1 over 5. So what we do is just we do the reciprocal of what we are given. Then if it was a positive, you add a negative. If it was a negative, then probably it will become a positive. Okay, so this is how we determine the gradient of the tangent and that of the norm. Supposedly in an exam, they ask you to say, find the equation of the tangent and the normal. Okay, find the equation of the tangent and the normal. So you can just find the normal and the normal to the curve. And the normal to the curve y is equivalent to 2x. Okay, 2x raised to the power 3 minus 4x. Okay, 2x raised to the power 3 minus 4 plus 2. Okay, at a point, we can say at a point 2, 1. At a point 2, 1. Please pay attention to this one. Okay, find the equation of the tangent and the normal to the curve at a point 2, 1. Now this is the curve here which we've been given. So the first step that we're going to do is that you start with that of the tangent. So here we'll say tangent. Okay, tangent. First of all, you differentiate the equation. Okay, you differentiate the equation. How do we differentiate? We can just say the difference in y over the difference in x. Now this is, remember, from the introduction of calculus which we did. Sir, can you just pick up? Okay. From the introduction that we did, probably this will give us dy dx is equivalent to, we multiply this, okay? 2x multiplied by 3, it will give us 6x, okay? 6x. So we don't do power, but we multiply. Then this 3, the power reduces by 1, minus 4x, then we have plus 2. Remember here there is an invisible 1, so this same 1 will reduce by 1. Under differential, the power reduces, doesn't increase. Then this one, we can just say it's a 0, or if we want, we can distribute it y because it's not a coefficient of x. Okay, so that will give us 6x raised to the power 2 minus 4x. This and this one, it will give us 0. According to the rules of index, we said that any number raised to the power 0 is 1. So that will give us 6x raised to the power 2 minus 4x raised to the power 0 is 1. Giving us 6x squared minus this and this one, which will just give us 4. We'll differentiate it. Now, after differentiating, the first thing for the tangent that you have to do is that you find the gradient of the tangent. The question is, how do you find the gradient of the tangent? So number 1, I said differentiate, you've differentiated. Number 2, find the gradient. Now to find the gradient of the tangent, we say gradient represented by m1 is equivalent to, we get the equation that we've differentiated, giving us 6x squared minus